Well, this section we're going to build mathematical models, so do a little application. This first one is a linear application. We've got a manufacturer buys a new machine. It costs $120,000. It has a useful lifetime of 10 years and a salvage value of $4,000 at that time. Find a linear function for the value of the machine after t years. So let's take the given information. In year zero, the machine costs $120,000, right? So if I was graphing this, this is the value, this is time in years. In year zero, it's $120,000. That's the value. And then after 10 years, it's only worth $4,000, right? So it has this depreciation. Whoops, I missed my point there. So after 10 years, it's $4,000. It's worth $4,000. So find the value. Well, to write an equation of a line, number one, we need the slope. So we got, here's my x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. What's that? Negative 116,000 over 10. So what this is saying is it's dropping $11,600 for every 1 year. Right? That's what your slope is telling you right here. Well, now that we have a slope and we have a point, let's use point slope form and write the equation. Let's add 120,000 to both sides. Now I really should have used the value v value as a function of t and t for time in years instead of x and y. So there's the equation for that situation. Let's do a profit one, the second one. Company is planning to manufacture a certain product. The fixed cost will be $500,000 and it costs $400 to produce each product. Each will be sold for $600. What's the profit equation? And how many units will be sold in order to break even? Well, number one, profit is how much you bring in revenue minus your costs to build the product. All your costs, right? That's your profit. Well, first of all, let's come up with our costs. Well, what does it cost to build this? Well, it's $500,000 flat. Those are fixed costs. Maybe that's like labor, the building, all that stuff. And it also costs $400 per times x. $400 per unit it costs to build whatever we're building. Okay. And then our revenue we bring in, we sell these things, $600 per unit that we sell. So finally, profit equals revenue minus cost. So the profit function will be revenue, 600x, minus the costs. Distribute that. Combine like terms. And here's our profit function in terms of x units. Here's our profit function. So Then it says, there's the profit equation. But how many minutes must we sell to break even? Well, if we're going to break even, so we're not making any profit, we're just breaking even. So 0 is our profit. We're making nothing, but at least we're not in debt. So I add 500,000 to both sides. Divide by 200. And I get, what is it, 2,500 units. So we got to sell 2,500 units in order to break even. We got to sell 2,500 units. If we sell more than that, in fact, here I can graph this thing. We're down here at negative 500,000. If I sell 0 units, I'm in debt 500,000. And then I hit, here's 2,500. 2,500 is the break-even point on this profit. So if I sell more than that, I am positive in profit, right? Anything more than 2,500 gives us a profit. Third example here, we got an open box. This is to be made from a square of material. It's 24 inches on a side. By cutting equal squares from the corners, turn the sides up, write an equation for the volume of the box. So write an equation of the volume of the box. Well, if you remember, volume is length times width times height. This is how much water you have in it, right? Volume is length times width times height. So here we've got our length is 24 minus 2x. Our width is also 24 minus 2x, and then our height is x. And so what we've got is x, and then we've got 2 of these 24 minus 2x's. And that's the volume in terms of x. X being how much you cut out on each side, right? Well, if we find the volume for a 3-inch square, so if this is 3 inches that's cut out, so the height is 3 inches, right, that we fold up, then what would the volume be? So we got volume, if I cut out 3 inches, let's see, 18 squared times 3, and by the way, this is inches squared times another inches. I get 972 cubic inches is the volume. Cubic inches, right? In other words, inches times inches times inches, cubic inches. All right, a couple more here. We got a wire this time. A wire of length 10x. Oops, I didn't do that very. Here's my wire. Oh my gosh, terrible. That's the best I can do. A wire of length 10x is bent into the shape of a circle. So imagine taking this, bending it into the shape of a circle. So it's 10x all the way around, right? That's our circumference of the circle. So their circumference, the length around, is 10x because we bent that, right? So the circumference is 10x. There's number 1. Express the circumference as a function of x. Well, part B says express the area of the circle as a function of x. Well, for part B, remember the area of a circle is pi r squared. If I know the radius, it's pi times the radius squared. We also know the circumference of a circle is 2 pi r, and we know the circumference is 10x. So what we could do is we could solve for r. So r is 10x over 2 pi, so 5x over pi. That's my radius, and now, since I know area is pi r squared, I can punch my radius in, which is 5x over pi. And I can square it. So pi 25x squared over pi squared, pi over pi, leaves me with a pi there, so I got area in terms of x is 25x squared over pi. That's my area of the circle as a function of x. Alright, how about this last one? Rectangle is bounded by the x-axis and the semicircle y equals the square root of 9 minus x squared. So here's the y equals square root of 9 minus x squared. That's that semicircle. And it says express the area of the rectangle as a function of x. Well, if you remember a rectangle, area of a rectangle is length times width, right? We got length times width. So for this rectangle in green here, I'm out x amount. X amount is from here to here. Well, there's two of those x's. So x plus x is 2x total length times the width. Well, the width, the height, is the y value. So the area of the rectangle is 2xy. Now what they want, so that's just the area. They want the area as a function of x only. So I don't want this y right here. Well, we know that y is the square root of 9 minus x squared. So now we're going to take this area, 2x times y, and we're going to plug that in for y. And that's the area in terms of just the x value. So as long as you know x, how far out x you are, you can find the area. Erase this. So for example, if I pick x to be 2. So I go out 2, I'm up here, this is my rectangle if x is 2. I could find the area if I go out 2 units by plugging it in. I'd get what that is, whatever that number is. All right, thanks for watching. See you guys next time.